In population genetics, the question has been debated whether the modern Turkish population is significantly related to other Turkic peoples, or whether they are rather derived from indigenous populations of Anatolia which were culturally assimilated during the Middle Ages. The contribution of the Central Asian genetics to the modern Turkish population has been debated and become the subject of several studies. Y-chromosomes from Turkey suggested only a 10% of Central Asian contribution. Another study suggests roughly 30% based upon mtDNA control region sequences and 1 binary and 6 street Y-chromosome loci analyzed in 118 Turkish samples. More comprehensive study determined the Central Asian contribution in Anatolia at 13%, the lowest among sampled populations. Similar analysis also estimated it at 13%. As a result, several studies have concluded that the Western Asia is the primary source of the present-day Turkish population. Central Asian and Uralic connection. The question to what extent a gene flow from Central Asia to Anatolia has contributed to the current gene pool of the Turkish people, and what the role is in this of the 11th century settlement by Oghuz Turks, has been the subject of several studies. A factor that makes it difficult to give reliable estimates is the problem of distinguishing between the effects of different migratory episodes. Thus, although the Turks settled in Anatolia with cultural significance, including the introduction of the Turkish language and Islam, the genetic significance from Central Asia might have been slight. Some of the Turkic peoples originated from Central Asia and therefore are possibly related with Xiongnu. A majority of the Xiongnu sequences can be classified as belonging to Asian haplogroups and nearly 11% belong to European haplogroups. These findings indicate that the contacts between European and Asian populations were anterior to the Xiongnu culture, and it confirms results reported for 2 samples from an early 3rd century BC Scytho-Siberian population. According to another archaeological and genetic study in 2010, the DNA found in 3 skeletons in 2,000-year-old elite Xiongnu cemetery in Northeast Asia belonged to C3, D4 and including R1A. The evidence of paternal R1A support the Kurgan expansion hypothesis for the Indo-European expansion from the Volga steppe region, as the R1A was found in Xiongnu people and the present-day people of Central Asia. Analysis of skeletal remains from sites attributed to the Xiongnu provides an identification of dolichocephalic mongoloid, ethnically distinct from neighboring populations in present-day Mongolia. According to a different genetic research on 75 individuals from various parts of Turkey, Mergen et al. Revealed that the genetic structure of the mtDNAs in the Turkish population bears similarities to Turkic Central Asian populations. Overall, modern Turks are most related to neighboring West Asian populations. A study looking into allele frequencies suggested that there was a lack of genetic relationship between contemporary Mongols and Turks, despite the linguistic and cultural relationship. In addition, another study looking into HLA genes allele distributions indicated that Anatolians did not significantly differ from other Mediterranean populations. Multiple studies suggested an elite dominance-driven linguistic replacement model to explain the adoption of Turkish language by Anatolian, indigenous inhabitants. Haplogroup distributions in Turkish people. According to Synthesized et al., there are many Y-DNA haplogroups present in Turkey. The majority haplogroups are shared with their West Asian and Caucasian neighbors. By contrast, Central Asian haplogroups are rarer: N and Q 5.7%, India HR2 1.5%, and Africa A3*, E3A 1%. Some of the percentages identified were J2 equals 24%, J2 typical of Mediterranean, Caucasian, Asian, Western and Central Asian populations. R1b equals 14.7% widespread in Western Eurasia, with distinct West Asian and West European lineages. G equals 10.9% typical of people from the Caucasus and to a lesser extent the Middle East. E3bm35 equals 10.7%. EM78 occurs commonly, and is found in northern and eastern Africa. Western Asia. Haplogroup EM123 is found in both Africa and Eurasia. J1 equals 9% typical amongst people from the Arabian Peninsula and Dagestan. R1a equals 6.9% common in various Central Asian, Indian, Central and Eastern European populations. I equals 5.3% common in Balkans and Eastern Europe, possibly representing a back migration to Anatolia. K equals 4.5% typical of Asian populations and Caucasian populations. L equals 4.2% typical of Indian subcontinent and Khorasan populations, found sporadically in the Middle East and the Caucasus. N equals 3.8% typical of Uralic, Siberian and Altaic populations. T equals 2.5% typical of Mediterranean, Middle Eastern, Northeast African and South Asian populations. Q equals 1.9% typical of Northern Altaic populations. C equals 1.3% typical of Mongolic and Siberian populations. R2 equals 0.96% typical of South Asian population. Others markers than occurs in less than 1% RHA, E3AO, R1 asterisk. Further research on Turkish Y-DNA groups. A study from Turkey by Gökümen took into account oral histories and historical records. They went to 4 settlements in central Anatolia and did not do a random selection from a group of university students like many other studies. Accordingly, here are the results. 1. At an Afsha village whose oral stories tell they come from Central Asia, they found that 57% come from haplogroup L, 13% from haplogroup Q, 3% from haplogroup N, thus indicating that the L haplogroups in Turkey are of Central Asian heritage rather than Indian, although these Central Asians would have gotten the L markers from the Indians from the beginning. These Asian groups add up to 73% in this village. Furthermore, 10% of these Afshas were E3A and E3B. Only 13% were J2A, the most common haplogroup in Turkey. 2. An older Turkish village center that did not receive much migration was about 25% N and 25% J2A, with 3% G and close to 30% of some sort of R1, but mostly R1b. Whole genome sequencing of Turkish genomes reveals functional private alleles and impact of genetic interactions with Europe, Asia and Africa. The latest study regarding Turkish genetics, from 2014, has utilized the whole genome sequencing of Turkish individuals. Whole genome sequencing of Turkish genomes reveals functional private alleles and impact of genetic interactions with Europe, Asia and Africa. The study, led by Kanalkan of University of Washington, Seattle, has been published in the journal BMC Genomics. The authors of the study show that the genetic variation of the contemporary Turkish population clusters with South European populations, as expected, but also shows signatures of relatively recent contribution from ancestral East Asian populations. They estimate the weights for the migration events predicted to originate from the East Asian branch into current-day Turkey was at 21.7%, a population tree based on tree mix analysis. The populations included are as follows: Turkey, Tuscany and Italia, Iberian populations in Spain, British from England and Scotland, Finnish from Finland, Utah residents with Northern and Western European ancestry, Han Chinese in Beijing, China, Japanese in Tokyo, Japan, Han Chinese South Yoruba in Ibadan, Nigeria, Lulia in Wibai, Kenya. Populations with high degree of admixture were not included to simplify the analysis. The Yoruban population was used to root the tree. In total, 4 migration events were estimated. The weights for the migration events predicted to originate from the East Asian branch into current-day Turkey was 0.217. For the ancestral Eurasian branch into the Turkey-Tuscan clade was 0.048. From the African branch into Iberia was 0.026. For the Japanese branch into Finland was 0.079. http www.biomed central https scholar google.com citations view_op equals view_citation and amp hl equals n and amp user equals 4 rigged carj and amp sort b equals pub date and amp citation _4_ view equals 4 rigged carj xud2gqfnedmc. Other studies. In 2001, Benedetto et al. Revealed that Central Asian genetic contribution to the current Anatolian mtDNA gene pool was estimated as roughly 30%, by comparing the populations of Mediterranean Europe and Turkish-speaking people of Central Asia. In 2003, Siniglu et al. Made a research of Y-DNA including the samples from 8 regions of Turkey, without classifying the ethnicity of the people, which indicated that high-resolution SNP analysis totally provides evidence of a detectable weak signal of gene flow from Central Asia. It was observed that the male contribution from Central Asia to Turkish population with reference to the Balkans was 13%. In 2006, Berkman concluded that the true Central Asian contribution to Anatolia for both males and females were assumed to be 22%. With respect to the Balkans, in 2011, Aram Yardumian and Theodore Gisha published the study Who Are the Anatolian Turks? A reappraisal of the anthropological genetic evidence. Quote, they revealed the impossibility of long-term and continuing genetic contacts between Anatolia and Siberia, and confirmed the presence of significant mitochondrial DNA and Y-chromosome divergence between these regions, with minimal admixture. The research confirms also the lack of mass migration and suggested that it was irregular punctuated migration events that engendered large-scale shifts in language and culture among Anatolia's diverse autochthonous inhabitants. According to a 2012 study on ethnic Turkish people, Turkish population has a close genetic similarity to Middle Eastern and European populations and some degree of similarity to South Asian and Central Asian populations. At K=3 level, using individuals from the Middle East, Europe and Central Asia, clustering results indicated that the contributions were 45%, 40% and 15% for the Middle Eastern, European and Central Asian populations, respectively. For K=4 level, results were 38% European, 35% Middle Eastern, 18% South Asian and 9% Central Asian. However, Hodoglugel et al. Cautioned that results may indicate previous population movements or genetic drift, given Europe and South Asia have some genetic relatedness. The study indicated that the Turkish genetic structure is unique, and admixture of Turkish people reflects the population migration patterns. Among all sampled groups, the Adige population from the Caucasus was closest to the Turkish samples. A group of Armenian scientists scientists conducted a study about the origins of the Turkish people in relation to Armenians. Savakavagyan, director of Armenia's Bone Marrow Bank, found that Turks and Armenians were the two societies throughout the world that were genetically close to each other. Kurds are also in same genetic pool. Other studies found the peoples of the Caucasus are closest to the Turkish population among sampled European, Middle Eastern, and Central, South, and East Asian populations.